Yeah, so far we have completed some data structures. Okay, and we have seen the support of Java for those data structures also. What are the different data structures you have covered? Array structure, linked list structure, tree structure, okay, stack structure. So some complicated structures we have covered. So in Java we don't bother about implementing the structure. We only study the behavior of the structure, how it behaves. So if you understand how it behaves, you can use that structure very easily. Okay, now see, one structure was supported by one class. Like stack structure was supported by which class? Stack class. Okay, array structure was supported by, means dynamic array. Dynamic array was supported by two classes, vector and array list. Vector is legacy, means synchronized, and array list is a new class and it is not synchronized. Then also we saw linked list. See, these are all very complicated structures. For us to implement it is very difficult. Okay, even in linked list, you have got some concept called as single linked list, double linked list. Okay, so we didn't worry about learning anything. We just learned how to use the linked list class. That's it. So you just have to understand now what in array list, what happens. It supports array structure. That's all. As a Java developer, you have to understand only this much now. In array list, duplicates are allowed. It will store sequentially and it can be accessed randomly. That's it. You know the behavior. Linked list, what it does? It will store randomly, but it will be accessed sequentially. Understood? And linked list, and it will use internally linked list for storing. You don't bother about that, how it stores and all that. So, and if it is you want fast iteration, you go for what? Array list. If you are doing too much of insertion, deletions and all, you can go for linked list. That's all. From the performance point of view, worry no. You don't worry about anything. Similarly, we studied which one? Tree structure, a tree set. It is supporting what? Tree set. So you just have to understand that tree set. What is the behavior of tree set now? It will not allow duplicates. It will store it in sorted order. That's it. Nothing more you have to worry. Internally, tree set is using so many algorithms. Means, see, in tree structure also, like how you have got in linked list, single linked list, double linked list, in tree also, okay, there is something called as balanced tree, imbalanced tree, a big subject it is. Okay, then you have got in balanced tree, you have got something called as AVL trees. One of the example for balanced tree is AVL tree. Another example for balanced tree is a red-black tree. So there are many tree algorithms. You don't have to worry about all that. Java is using which one? Red-black tree, and it is a balanced tree. You don't have to worry about it. That's it. So tree set is implementing that algorithm. You don't have to worry. But on the top, as a user, what should I worry about tree set? Not all this. In the entry also, they will not ask you all this. They will just ask you the behavior of what? Tree set. It will not allow duplicates and store it in sorted order. That's it. Nothing more you have to worry. So all these complicated structures are hidden behind now, and Java is giving you beautiful support for this data structures. Now how does Java give powerful, means this support now with the help of OOPs. And you can see how OOPs has been implemented now. To implement all this complicated things, what they are doing? They are using OOPs. Now how is Java using OOPs to implement all that? How is Java implementing OOPs now? With the help of Java's data types. How is Java implementing all these OOPs concept now? Data types. Which data type? Linked list. These are all classes, interfaces. So they are using all these data types to implement the OOPs concept now. This is how Java has been designed. So it will encapsulate, understood. And whenever you want, you can create the object, bring it into existence, start using it. That's simple, they have done for you. So you just have to worry about the behavior of the structure. Understood? So it's something like, you don't want duplicates, you want it in sorted order, just decide to go for tree set. You want duplicates, fine, two options are there, array list and linked list. Decision is yours now. You want too much fast iteration, go for array list. You want to do too much of insertion deletion, then go for linked list, like that. Stack, okay, first in, first out. So generally we don't use, because from practical point of view, if you see in our applications, we'll never use the stack structure. Reason is it will degrade the performance. Understood? But support is there for us. So this is what you have seen till now. So pending are, see, we have to study these two things now, HashSet and linked HashSet. So obviously these are two classes, means it will be supporting what now? Some data structure now. So can you guess? So today we will see the topic of what? HashSet. So can you guess now? So you don't have to worry, understood now? All the algorithms like what? In linked list, don't worry about single linked list, double linked list. Okay, in tree, don't worry about balanced tree, don't worry about all that. Balanced, imbalanced, red, black tree and all that. Just understand the behavior. Tree will allow you what? No duplicates, no null values. That's all you have to understand. Nothing more about that. Clear? In the interview also tell that much only. Okay, so today we are going to see what? HashSet now. So HashSet is one more class which supports some data structure now. Can you guess which data structure it supports? There's one more way you can store values in the memory. Okay, it supports hash table data structure. So this is also a very complicated data structure, but Java is being down to earth for you to work with that data structure. Understood? So it provides hash table, HashSet provides support for hash table data structure. Understood? So directly what we'll do, we'll see the output of how the HashSet is. Okay, we'll see the behavior. Okay, then we'll understand the data structure. It will be very easy for you. Understood? First we'll understand the behavior of this HashSet, and then you can understand the structure very easy. Understood? Then we'll study the data structure. So for understanding that, what we'll do, we'll revisit the examples. I had shown you just when I started the collections, I had shown you an example for what? HashSet. So in that example, what did you learn? HashSet does not allow duplicates. Yes? So that is the behavior of HashSet. It will not allow you what? Duplicates. Any class which is implementing set interface, remember, it will not allow duplicates. So HashSet also is not going to allow you duplicates. And apart from that, what is the order it will store? Random order. So you know a little bit the behavior. Plus, okay, that's the behavior of HashSet now. It will not allow, see we are going with HashSet. After completing this, then we will go with linked HashSet. It's a subclass of that. So HashSet, okay, will not allow duplicates because it's implementing set. Fine. Then it will not, means it will store in random order. It will not store in the same order as you are inserting also, nor in sorted also. So the order is undefined here. You don't know in what order the elements will be stored here. That is the behavior. Why and all we'll see next. Understood? That is the behavior of that structure now, data structure. Which data structure? Hash table data structure. That's the behavior. Then next, it will allow dissimilar elements. That's the behavior. Then it will allow null values. As a developer, as a Java developer, you should understand only this much. So if your requirement is you don't want duplicates, okay, if you don't want duplicates and you are not bothered about the order, and you want dissimilar elements to be stored, you want null elements to be stored, better you prefer HashSet. That's it. Understood? So that's how it goes. So we'll see with an example. Okay. I had shown you the first example long back. Let's see the output now. See, this is how you create a HashSet. HashSet set is equal to new HashSet. Then we can call some methods. Which are the methods? Set.size will be what? 0 is empty will be what? True. Then values, no values will be there. I can add, yes. I cannot add duplicate. I show you. First I'll run this program. But anyway, just understand you cannot add duplicate in HashSet. Then next you cannot add, we can add null value. We can. So size of HashSet after adding elements, okay, you'll see it. And after that, display the contents. We are displaying it. Then if you want to check, you can check set.contains. So these are all methods coming from which interface now? Collection interface. HashSet is implementing set. Set is again extending collection. So remember this hierarchy. HashSet is implementing set. Set is again extending collection. So we are seeing some of the methods present in collection first. Then we'll come to all the methods of HashSet. Clear? So that's the route we'll take. So contains. And remember, HashSet is always used for this purpose only. The searching is very fast in HashSet. Okay, the main reason why we use HashSet is from performance point of view. Because searching is very, very fast in hashing technique. Understood? I'll explain you. But this contains now. Okay, so see, checks whether an element is present or not, but it is searching at a very fast rate. I'll explain you that. Just keep this in mind now. So the main reason why I use HashSet is because of its fast search rate support. Fast search rate support. Yeah. Then clear. So these are the methods. We'll run this. Yeah, initial size is 0, you know that. So start off from the beginning. Initial size is 0. I'll add some values. So after adding the values, means is element is empty is what? Sorry. Before when I create the asset, that is 0. Is empty is what? True, and there are no elements. Afterwards, what I'll do? Add the values. So let's see now. I've added these many values. See, look at the order I have inserted: C, A, E, B, D, F. Correct? Now see, after inserting, this is the order I have inserted. Now size is what? 7. Is empty is what? False. Look at the order here. You inserted in this order, but how it is stored now? Unpredictable, random order. I have added null also here later. Okay, but it is storing in some order which you can't predict now, because that's the behavior of what? Hash table data structure. That's the behavior. We'll see that structure later. Then if I want to check whether an element is there or not, just I'll call what? Contains, but it is lightning speed. Okay, so it's better than other structures when you are searching an element. Okay, I'll explain that concept. Okay, then next, value E is present true, value R is present false. Then I'll delete. Yes, after deletion, how many elements are there now? 6. Look at this order, fine. Then after clearing, after you call the clear method, what happens? All the elements are deleted and the elements are not present in the set now. There are no elements now. If you print in the last contents of HashSet after clearing, it will be nothing. So this is how it behaves. So we had seen this example when I had shown you the first time when I introduced HashSet. I had shown you typed this program for you and shown you. Done. So just I revisited it for you. Fine. Now let's see the second example of HashSet. Now how do you add? So in this example, okay, I'm showing you one second. So you see the first example. We'll try to add the duplicate here. Let's see what happens. I'm adding what? A is already there in the first example itself. A is already there. So what happens if I try to add? So this method name you change it to set. Okay. So I added. Do you find 2 A's here anywhere? No. So it clearly shows that it will not allow duplicates. That's the behavior. Just understand it. As a developer, you have to understand only this much about HashSet. It will not allow duplicates. It will allow null values. It will allow dissimilar. That next I will show you. Okay. So see the next example now. The second example, what you understand now? See here. You can add dissimilar and null values. See here. You can add what? Integer, null. If you want, you can add duplicates. Try it. But it will not allow you. You cannot add duplicates. Understanding the behavior, no? So all I have covered here. See here. Can add dissimilar and null values. Can add. But you cannot add duplicates. Simple example. Notice. So I added what? Null, fine. It is accepting null value. D, E, fine. 100 is there, but 100 is what? Dissimilar. It's of type integer. Okay. Then you can add duplicates. Try adding it, but it is not there. Where are 2 D's? Only 1 D is there. So the other element will be skipped. Okay. So the return type of add here is Boolean. So this time it will be what? False. First time it will be true. Second time it will be false. Okay. So here the return type is Boolean. If you want, you can accept and check. It will be false. The first time you add, it will be true. Okay. So this clearly shows the behavior of the second example. Clearly shows the behavior of what? Hashing thing. Are you clear with this? Dissimilar elements are allowed. Null value is allowed. But only duplicates are not allowed. Yeah? Okay. So second example. Next. So here I am covering two concepts. How do you add primitives? Just now I showed you how to add primitives. What do you have to do? You have to convert the primitive to objects. You have to do boxing and add it. Okay. So that's what we are doing, and at the same time I am showing you how to visit the elements. How do you visit the elements? You can use only iterator. You cannot use what? List iterator also, enumeration also. Yeah? Two concepts covered in the same example. How do you add primitives plus what? How do you visit the elements? Nothing more here. Getting it now? Very simple. So let's see. So there are two outputs. One I am printing SOP is set, so it will print all the values. The other output is using what? Iterate. Getting it now? Clear this example? Clear? Okay. So that is all about HashSet you have to understand. But to cover this lot, I'll cover. Okay, means definitely you are interested now. What is this data structure, how it works, all that you want to know now, I'll cover. But from the developer's point of view, you should understand only this much. We'll cover more topics. And what I'll cover now, in fact, this is really important from SCJP point of view also. It is definitely asked in every interviews. Okay, wherever you are, they'll ask you, interviews they're asked, SCJP it is asked. Okay, so most important concept now. And you will be also using it in real life programming. So what concepts I'm going to cover now is advantages for you from 3 points. What is that? From real life usage. When you're working in industry, you'll be using this concept. Second is for SCJP point of view. Third is what? For a military point of view also. Okay, so we're going to cover now. Let's start learning this now. So first, we'll understand. See, to understand the hash table data structure, you have to understand something called as, first, to understand, this is the route you are taking now. To understand the hash table directly, you can't understand what is hash table data structure. You will not understand. For that, you have to understand first the hash code method. You have to understand first. If you understand this hash code method, then you will understand that hash table data structure. So first, I will cover this hash code. If you remember, this method I had taught you when I was teaching you class object, but I didn't cover it fully because there you didn't have understood the concept. I just introduced. This is a method which is present in class object. Yes, it is present where now? Class object. And the return type of this is what? The return type of this method is int. So this is the method now. Clear now? It is present in class object. So definitely this method is available for what? Every class in Java. Because all classes are extending what? Object. So we'll see how crucial this method plays a role now. Understood? So this method plays a very crucial role when you are adding elements in what? Java. Collection classes which use hashing technique. This is where this method becomes important. Okay, this method plays a very important role when you are adding classes, when you are adding your elements into collection classes which use hashing technique. It's very important. So first we'll understand this method, then we'll talk about that data structure. Understood now? So just concentrate on what now? This hash code method, nothing else you worry now. We'll see the data structure later. Yeah, so to what I'll do is, I'll code now and I'll show you. See, there's a test project. You know, no? We have kept this test project for what? Some R&D purpose. So just I'll code it there only. So I'll have a new class called as hash code demo. Yeah. So string s1 is equal to GLLO. There is one string I got. Just focus on the hash code method, nothing else you focus. Understood? So hash code is so and so. Then we'll run the program. Yes, this is a hash code value. Understood? Next. I have another string s2. I'll use new. Okay, here also I'll use new. Yes. Then we'll see the hash code of the second string. Hash code of string s2 is equal to s2 dot hash code. So every object in Java has got hash code, remember that. Every object. Okay, just remember that now. Slowly I'm moving now. So you can see both are okay. I just used high, I'll use. Yeah, see the hash code of hello is this much, some value, don't worry what it is and all, no? And the hash code of hi is 72304 or something. Fine. And don't think it will be same in every JVM. In your machine you might get a different output, but just understand it is generating some, it is returning you some integer value. This hash code method is returning you some integer value. Fine. So after that, what I'll do is boolean b1 is equal to s1 dot equals of s2. Both s1 and s2 strings are equal. Are they equal or not? How do you check their equality? Plus what? How do you check the equality? By calling equals method. So definitely they are not equal now. Both s1 and s2 strings are equal or not? So then you'll understand they are not equal. False. Fine. Then next I'll see one more thing. Boolean b2 is equal to s1 comparison operator I'll use. So what will the comparison operator check? References, whether both refer to the same object. We are moving just into the basics. If your basics are correct, all this will become very easy for you. Boolean b2, so both s1 and s2 strings refer to same object. So are they referring to the same object? No, check this out. So it is what? False. False. So they are not equal. And also they are not referring to same object. Now, see something here. Now S1 and S2 are having what? Same values. Yes or no? They are having same values. Now what do you think? Okay, hash code will it be same or different? It will be same. Just say this. Observe all this now. S1 dot equals of S2 will be what? False. It will not be true. It is referring to two different objects. Proof, check this out. So even though they are two different objects, they are having what? The same hash code. Understand that now. See, hash code is same. Both strings are equal, true. But are they referring to the same object? False. Both are not referring to the same object because S1 is referring to a different object, S2 is referring to another object. Are you clear this? Okay, so we'll comment this. Let's check with integer also now. So same thing I'll code now, but I'll use what? Integer x is equal to new integer of, I'll use some value like 5. Hash code of integer x is what? X dot hash code. Let's see this. So it will also have some hash code. Let us see what is hash code. So the hash code of integer x is what? I am not printing SOPX, I am printing what? X dot hash code. The hash code of 5 is 5 only. Okay, so one object will have one hash code value. We'll see how it is getting generated, but just check this out. Okay, so then next, integer y is equal to new integer of 10. Fine. Now I'll print hash code of integer y is y dot hash code. Fine. Now see, what will be the hash code? Different. That's all you have to understand. Don't worry about the value. For x it is having 5. That means for this object, x object, it is having the hash code as 5. For y object it is having the hash code as 10. Fine. Now I'll check whether they are equal or not. So how do you check whether both the integers are equal or not? Just I'll call x dot equals of y. That's it. And then I'll print what? Both integers are equal or not. Both x and y, both integer x and y integers are So what will be, are they equal? No, false. So hash code is different, plus what you are saying, even equals is also false. The value is also false. Means the equals method also giving false. Whether they refer to the same object, we'll check that. X is equal to y. Then both x and y refer to the same object. Fine, what it is? They are not referring to same object. Fine. Now I'll just change this value of y to 5 now. See this, a small change. Now what happens? Hash code will be same. Equals will be true. But they are referring to different objects. Again, same thing. What you saw in string, same thing is getting applicable here. Understood? So equals is true. Hash code is same. Okay, equals is true, hash code is same, but they are referring to different objects. Understood? See, in the previous one, S1 was referring to a different object, S2 was different to a different object. Okay, this was hello, this was hi. So it had some. Okay, we'll see the first program now. Then we'll see this. Yeah, first I'll go with a different value. See, hash code of S1 is what? Something 69609650, something, that's the hash code value. For S2, what is the hash code value? 103056. Fine. So when you say compare now, S1 dot equals, you call the equals method. Is it same? No. Are they referring to the same object? No. And what is the hash code? Different. Fine. Understood this. Now I'll change this to hello. Now see what happens. This is when string values are different. That is hello and hi. Fine. Now this is okay, different. Now what I'll do, I'll run the program. I just copied and pasted. Now see this. Both are hello now. See the output. When string values are same. hello and hello this time. Okay, so see this, it's having the same hash code now. Hash code is what? Same. Hash code is same. Equals true. Are they referring to the same object? False. Clear? So two objects can have the, what do you understand now? Same hash code, but they will be referring to different objects. That is one way you can see. Other way around, when two objects are equal, their hash code should be same. Put it like this now. Remember this point now. When two objects are equal, this is a rule now. When two objects are equal, then the hash code of both the objects, this is the important rule now, should be same. Now we'll see whether this is applicable to what? Integer class. We found out something now. When two objects are equal, their hash code should be same. Let us see whether it works for what? Integer now. Are you clear this now? So there are two different objects. You call equals, it's returning true. Okay. So because they are equal, the hash code is what now? Same. Understood? We'll see what the hash code is. Just concentrate on the hash code method now. So then next, we'll work with integer. First x and y is what? I'll take x is 5, y is 10. Let's see the output now. So we have got two objects now. One is x. What is the value of it? 10. We have got one more. What is the value of this? Sorry, x is 5. Y is 10. So this is the value. What is the hash code of x? 5 is the hash code. It is taking the same value as what? Hash code. And it is taking the same value as hash code. This is the hash code of y. So again now you check. Hash code of x and y is what? 5 and 10. Are x and y equal? No, because when you call x dot equals of y, it will check the contents and will give false. Are both referring to the same object? No, false. That also is false. Both are not referring to same object. Both are not referring to same object. Fine. Now see, what I'll do is, both I'll make it as what now? 10. Now see what happens. Both equals will be true. But if they are true, their hash code should be same. That is the rule we learned now. If two objects are equal, then their hash code should be what now? Same. See there. Are you getting this concept? When two objects are equal, then their hash code should be same. So what is the hash code of x and y? 10 and 10. Are they equal? True. Means if they are equal, that is why their hash code is same. Understood now? They are equal, true. Because they are equal, their hash code is same. But they are definitely referring to what? Two different objects. So two objects can have the same hash code value. Understood? Fine. So you are clear with this much? Okay. So now, if you understood about class string and class integer, let's see what they have done, the implementation. So let's go to the source code and we'll check it out. I'm going to the source code. You extract rt.jar. Sorry, src. In src, what will you find? Java. In Java, what do you go? Where will you go now? You are dealing with which classes? A string and integer. So they are present in which package? Lang package. Go to lang and go to string now. First I'll go to integer class. Yes. So we'll check now. Control F hash code method. We'll see how they have implemented now. In class integer, let's see how they have implemented the hash code method. What are they doing? Returning the value stored. That's what you saw now. If I say integer x is equal to new integer of x, that value of x is stored in what? In an instance variable called as value. See there on the top you can see. This is the source code. Just I am showing you the source code. Min value, max value, Okay, it will return the value what it is stored, that's it. So you don't worry more about that now. And this is the source code I am showing you. But you got the idea about the hash code now? So what it is doing, it is returning the same value what it is storing. Now let's see what they are implemented in what? String. So here they implemented some complicated logic, don't worry. But this is actually what gets executed when you call the method. Okay, so this is what they implemented for string class, and that is what you saw they are implementing for integer class. Okay, means simple what you have to understand is class string and class integer are overriding what? Hash code method. That's what you understand. They are not using the default implementation. Both these classes are using they are doing their own implementation. Similarly, all wrapper classes are implementing which one? Byte, short, understood, float, double, they are all overriding all wrapper classes are overriding the hash code method, plus string is overriding the hash code method. So that is why very easily you are able to store in what? HashSet. Okay, if you want your elements to be stored in what? Any class which uses, any collection class which uses hashing technique, you have to see to that class is implementing hash code method. Understood? We'll see. We'll understand that point. Anyway, we are just talking about the hash code method. Now, let's come to our class. We'll have an employee class now. See, these are the built-in classes you saw. Fine. Now, we'll work with our classes, our user-defined classes. See, I'll take the class employee. You know, we have got a class called as employee now. We'll take that. Yeah, I found it here. It was there in the previous examples. We'll see what is the hash code generated for. I'm pasting it. Just if you want, you can code it. See, this is what it is. A simple class. I'll remove everything. Nothing is there here. So this is our user-defined class now. So what happens if you don't override? Question is that now. Understood? What happens if you don't override the hash code method? Let's see. So we are done with built-in classes. So same program I am continuing now. It's an R&D we are doing, that's it. See, employee. I will take the code from there itself. So you should know where your code is. That easy it becomes to code. Else you'll have to struggle. So we got two employees. Got it now? I've created two employees, employee 1 and employee 2. Now, we'll check what is the hash code of both of them. Hash code of employee 1 is, hash code of employee 2 is. Hash code of employee 2 is, we'll see both the hash code now. See the output what you get. What is the error? See what is the hash code you are getting? Did I override? Did I override? I didn't. See, this is my class employee. Nothing is there, only properties. Segregator methods are there. So when I don't override, what happens? The superclass, the method of class object gets executed. So now what has happened? You got employee 1. What are the values of employee 1? 101 A, some 111 is the phone number, aa@gmail or something. This is employee 1. Similarly, I got what now? I need space, 1 second. This is employee 1 now. What are the values of employee 1? 101 aa, phone number is 111 a@clusterindia.com or something. Okay, employee 2. What are his values? 102, BB, phone number is 222, BB at the rate of, means ID is, you know, the properties, not? So for the corresponding properties, these are the values. Now what is the hash code it generated? Some value it is generating. See this 1671711. Okay, 11. In your machine, don't expect it to be the same thing. Understood? I'm just giving you the idea what is hash code here. 4033. So this is what is the default implementation. Okay. So now what I'll do. Okay. I'll check whether they are equal or not. You know how to check now? How will you check? By calling what? Equals method. Employee 1 dot equals of employee 2. Both employees are equal. What will be the answer? False. Why? Because it is checking the reference. Remember that even if the values were same, it would have been what? False only. Yes or no? Why? Because the default implementation of equals checks for what? The reference. See this, if you want to make it as 101, A 1111. Okay, then I'll change it to AA. Just observe now. So what will be the equals method now doing? Checking the reference. That is the default implementation. So by default equals also has been implemented. Hash code also has been implemented. Where? In class object, and it is giving a false. By default, class object is doing it. But we have to override. So now we will discuss why we override that. Why we override equals plus hash code. Understood? So default they have implemented in class object. Okay, let me bring it back. Okay, this is how it is now. Fine. Then we'll check whether they are referring to same object. You know how to check now? Boolean B2 is equal to employee 1 is equal to employee 2. Sorry. EMP1 and EMP2 refer to same object. It is false. They are not referring. They are referring to two different objects. Are you clear this? That's fine. And now, first I'll teach you overriding hash code method. Then, because we know how to override equals method, let me concentrate on what? Hash code method. So you can write the logic for hash code now. Public int hash, because say I don't want that default implementation. That's why I am overriding. You know why you override? Not to change the logic. So I'm overriding. The return type of hash code is int. Remember that? So I have to return now. So RETURN. I have to return what value? Some integer value. So I'll return 999. Yes, I'm returning what now? 999. Now see what happens. Okay, you should not hard code like this. But this is a correct one. I'm not saying it is wrong. But for efficiency it will be bad. I'll tell for efficiency why it will be bad. Okay. If you're adding these employee objects into hash into classes which are using hashing technique now, the efficiency will drastically go down. Okay, we'll see it first. We'll talk about using hash code in those collection classes later. But let's see whether it runs or not. Yes, you can see that both objects are having what? The same hash code. True. They're having the same hash code. Then both employees are equal. No, false, because it's checking what? References. And both refer to the same object also. False. Understood? Okay. Now we'll see now what it means. Why this hash code is so important. See, in the hashing technique what happens is, see, the hash code is same now because I override 999 999. So E1 dot equals of E2 is what? Equals method, false. And if you use a comparison operator also it is false only, because they are referring to two different objects. Fine. So if you got this till now, so let's come to the concept of hash table now. Okay. So hash table is also one more data structure now, where you can store the values. In the hash table, there are two things. One is called as the hash code, and the other is called as the value. So to store a value in a hash table, so what does the hash table contain now? This is the hash table data structure. This is how it looks. You know how a stack structure looks, you know how a tree structure looks, you know how a linked list structure is. So now we are studying what? Hash table data structure. This is the first time I am drawing now. About what? Hash table data structure. Most of you know this, fine. Most of you don't know, it will take some time for you to understand. So anyway, it will have two things. One is the hash code it will have, and the other one is the value it will have. Okay. See now, when you try to add these elements now, like string elements, integer elements, or your employee object and all, into hash code now. Okay. See, in this table, there is something called as, we'll be having like this, and these are called as slots, or they also sometimes called as buckets. Each partition here, what you're saying, they are called as what? Either slots or buckets. Okay, you can use any word, slots or buckets. That's the word they use when they discuss about what? Hashing technique. See, in array we talk about index, in linked list we talk about nodes, in tree also we talk about nodes. Same way they have got some terminology here, slots or buckets. So now see, when I am inserting any value, supposing I say set dot add, which one? HashSet dot add. Okay, set dot add, I'll say C. So that hash code value will be taken now. The hash code value of what? String C. When I say string S1 is equal to new string of C, it have an hash code now. So that hash code will be taken. So hash code value will be here something like 6958, something like this, and value is what? C, like this. Similarly, when I add set dot add B, so B will also have what? They are all string literals now. They are all string literals, means they are objects. So that string object will have what? One hash code value. So that hash code value will be taken again. B means what? 79,586, something like that. Approximately I am writing. So B will be stored here. So the add method of set goes on invoking what now? The hash code method now. Which one? The add method of set goes on invoking what? The hash code method. So once it gets the hash code of that object, that will store as in the hash code side it will store, and the value it will be storing in the value side. Like this it goes on. Supposingly now when I write, means when I add these two employees now, set dot add. Now forget these two strings. Assuming that we are adding what? Employee. Set dot add employee 1 and employee 2. So when I add these two, what happens? Yes, they will also hash code now. Either it will use the default implementation or it will use your implementation. So default implementation was giving different number values. Default, when I didn't override, you saw now what was the value it was giving you? 167171, something like that. When you don't override, so it will store like that, 1671711, and employee 1 will be here now. Then 11394033. So when you don't override, this is how it will be stored. When you don't override, so this is how it is stored. When you override, understood? When it means in every value you can see that it is getting stored in one what? Slot. Every value is getting stored in one slot now, one bucket. Like that it is getting stored now. Supposingly I override in class employee, I will override hash code, and what value did I return now? 999, no? 3 nines or 2 nines? 3 nines, yes. So now there will be only one slot, and both the employees will be stored in the same slot. Understand this problem now? Understand? It will work. I'm not telling you if you don't override or it will work. If you don't override, means if you don't override also it will work. Okay. If you override like this also it will work. But there are some problems. So I'm going to tell you what are the problems if you don't override hash code properly. So I'm overriding. This is legal because the return type of hash code is what? Int. But the problem is it is storing all the objects in what now? Same slot. So rest all slots will be what now? Empty. Understood? And think that there are different hash tables. This is for employee string. I'm just writing all in only one place. Think this is for string. I create one hash table is getting created. This is for what? Employee, and this is another one now. So one more I will have employee 3. What happens now? It will also go into that same slot, and all these other slots will be what now? Empty. So you're not using the entire hash table efficiently. So if all your values go on getting stored in the same slot, understood? For built-in classes it will never happen. Why? Because they're implementing the hash code properly. For string class, integer class, it will never happen. But if you override and if you give out, means if you return on fixed value like this, all your employee objects will go on storing in the same slot and other slots will be wasted. So what happens now? When you start searching now, okay, so first anyway, we'll see when you search, that is the problem. If you don't override it properly, search is the problem now. It will go to that slot. When you say contains or get or something like that, it will go to that slot. Now it has to check each and every element. So to check each and every element, what it has to call? Equals method it will go on calling now. So remember, when you are searching an element in HashSet, okay, it will be calling two methods. One is the hashCode and the other one is equals method. So remember this, when you search an element in HashSet or any class which use hashing technique, okay, first it will find the bucket, means in which bucket is that value. Second, means how does it find the bucket? By using hashCode method. Now then it will find the element by using what? Equals method. So more elements you dump inside one slot, your search becomes slow. Understood? More elements you dump inside only one slot or one bucket, what happens? Your search becomes very slow. So that is why you should see to that all your employees are getting spread in what? Different buckets. Should see to that that all the employees will be stored in different buckets. So now I'm showing you how to override hashCode properly. This is working, but the problem is all will be stored in the same bucket. So let's see how you do it. One option is I can return what? Okay. So the best way what we do is, there are so many PhDs done on this, what is the best hashCode generating algorithm you can write. Okay. But always preferably when we generate the hashCode for any object now, we should use all the values stored in that class. We should use all the values stored in that particular class. Which values are? Instance variable values. And then generate the hashCode. So see this now. How will I do it? So we don't write any logic. You know, there's on what? If you want, you can write logic like this. But if you write, we'll end up writing what? Some wrong logics like this. Understood? So that's the reason what we can do. We can override now. And what we do, we'll take the help of the Eclipse tool. Eclipse only will generate what? A beautiful hashCode generating algorithm for you. Understood? So we'll see this now. So these are the two key points now. When two objects are equal, then the hashCode of both objects should be same. That is how you have to override now. And other thing is, when you search an element in the hash set, means this is how it will search now. So let's see now how it happens. So now I'm overriding. See this now. When I override, source generate hashCode using all the elements, means all the properties I'll generate, and I'll say okay. Okay, it came off here. 1 second. Right click, source, generate hashCode and equals. Okay. So see, I'll remove the equals now. It is mandatory to override both, but just I'm focusing on what now? hashCode. It's mandatory you have to override both. Otherwise, okay, we'll see what happens. See this. So you can write, but here what is the logic they have written? See this. See, they have taken one prime number, okay, and result is equal to 1. They have declared one more variable. Now what they are doing is, result is equal to prime number into, what is that? 1. Understood? So there are so many complicated algorithms you can use for generating what? hashCode. Okay, but the best one is always to use the your values which have been stored in the instance variable. So use the instance variable values for generating your hash code. But I'm using it, but look in what way I'm using. Prime number into result plus, see here, I'm using a ternary operator. What am I doing is, email is, if email is null, I'll use what? 0. Or I'll use what? The hash code of the email. Okay, but email is string now, so it will have its own hash code. So you are using that hash code. Then what you are doing, result is equal to, again, it will get, you are having one result now. Then again I'll say prime into result plus employee ID. So you're using all the values here, employee email, employee ID. Then again I'll say result is equal to prime into result of what? If name is 0, it will take 0, or it will take name dot hash code. Like that, finally one hash code you will get. One hash code value you will get. It's not like 999 or something now. So definitely when you create employee 1 now, what is the hash code value? We'll see now, this time. So this time we are not using the default implementation. We are using what? We are overriding and using our implementation. Let's execute the same code and check now what happens. Same printing, employee 1 dot hash code, employee 2 dot hash code. Some value it is generating. Some unique value it is. Means it is using our logic and generating the hash code. Yes. So now what I'll do, I'll override the equals also. Okay, means you know the rule now. When two objects are equal, their hash code should be same. Till now what was happening? Our objects are not same, but still it was having what? Same hash code. But now what is the rule? Whenever two objects are equal, they should have the same hash code. So let's see now. I'll override I'll override both now. Now I'll show you. Right click, source, I'm overriding. I just override both hash code and equals. I deleted that and I again generated. See, now we have got the hash code also, plus we have got what? Equals. Equals, you know now, it will check now what? The contents. This logic you already know now. Fine. Yes. So now we have got two objects. Now we'll check whether they are equal. Now equals will be calling which method? Our method. It will not check the reference. Yes. Now look at this. So equals is calling which method? Our method. And definitely the values in both objects are not same now. Fine. Now I'll create one more object. See here what I'll do. I'll create one more object now. Employee E3. And it'll have, sorry, I'm changing the variable name to E3, employee 3, yes. Now, there are 3 employees. See, now I'm checking hash code of employee 2 and employee 3. Then also, I'll check employee, this employee 1 and employee 3. Then also I'll check employee 1 dot equals of employee 3. Then I'll check whether they are referring to same object. Yes, we got it now. Finally, our hash code and equals method have been implemented perfectly now. See, hash code is same, both objects are equal, true, but they are not referring to same object. So you should write a logic in your hash code. When you generate a hash code now, you should see to that it should generate it in such a way that when an identical object is created or when two objects are equal, then the hash code of both objects should be same. That is how you have to write. Simply don't return 999. 999 will do what? For all objects it will be equal. Understood? But actually the hash code should be same only when both objects are equal. That is the way you have to write. This is the correct way of writing what? The hash code logic. Okay. So you don't bother about writing anything. Simply generate it by using what now? Eclipse. Simply generate it by using Eclipse now. Clear now? That's all you have to understand now. So yes, we understood what is the hash code method and equals method of what? Class object. We generally override it when you want to, we override both. Okay, see, equals is overridden when you want to check the equality, and hash code is overridden when you want to add your element into collection classes which use hashing technique. I'll tell you that also. We are coming to that point now. Understood? Anyway, you understood both of these methods, how to override and all that. Done. Now, okay. So, yes. What are the rules for two objects to be equal? Some notes you take. This is very important now. What are the rules? To be considered for two objects to be equal in Java. Means when do you say two objects are actually equal in Java? See, if two objects are equal, they must have the same hash code. Remember that. Okay. But if two objects have the same hash code, they need not be equal. True or not? If you hard code return 999, all objects are having what? Same hash code, but they are not equal now. Understood now? So, but the rule is what? If two objects are equal, then they should have the same hash code. That is the rule. If two objects are equal, then they should have the same hash code. But the reverse is not true. Okay, if two objects have the same hash code, then they need not be equal. I showed you an example for both. Clear? Means hard code 999. Return in hash code what you do? Return 999. Two objects will have what? Same hash code. You call the equals method now. See this. Instead of using the default implementation, what will I do? Sorry, instead of using good implementation like this, I'll hard code return. Now what will happen? Employee E1 and E2 you check. They'll have the same hash code, but they are not equal. E1 and E2 you check. E3 is okay. Okay, but E1 and E2 you check. Employee 1 and employee 2, they'll have the same hash code, but they are not equal. Why? Because employee 1 is having a different value and employee 2 is having what? Different value. Are you clear with this? Just check this out. Understood? So always remember this important point now. It will take some time for you to understand this concept. Okay. So if two objects are equal, they should have the same hash code. But if two objects have the same hash code, they need not be equal. That is the rule. Fine. Now see this next point. If two objects are equal, that is object 1 dot equals of object 2, if you call the equals method, is true, then obj dot means object 1 dot hash code and object dot hash code must return the same hash code value. This is the rule. That's how you have to implement it now. When you implement hash code method, this is how you have to write. But we can't write good logics. That's why what we do, we use the support of the editor. Which editor? Eclipse. It will only generate the code like this and give it to you now. Otherwise writing this code is very complicated. Understood? So we use the help of the Eclipse tool. Fine. Next, if you want to treat two objects as equal, then you must override the hash code and equals. Otherwise they'll never be treated as what? Equal. From the equals point of view also they are not treated equal because it will be referring to what? To different objects. Understood? And that means it will be checking the references. The equals method will be checking the references, sorry. Okay. So that's why if you want to treat two objects equal, then you must override both these methods. Now what is the best way to override hash code method? You can override in many ways. You can hard code, do anything, you can write any algorithms. Okay. But you should see to that. See, the best way to override hash code method is to use all the values of the instance variables of the object and then generate the hash code. Fine. The hash code value should be same for two objects whenever an identical object is created now. This we are coming to a very important point now. When two identical objects are created, which are the two identical objects? You can see that employee 3 is an identical object now. But can you guess? Can you see that now? Employee 1 hash code and employee 3 hash code is what? Same. The employee 1 hash code and employee 3 hash code is same. Even though they are two different objects, the hash code is same. And equals method is also what? Returning true. This is very crucial now. This is the most important thing what you have to understand. Yes, see this now. See employee 1 and employee 3. See this. When you run the code for employee 1 and employee 3, it will have the same hash code. So when you create an identical object with the same values, the hash code should be same. This is how you have to write a hash code method. When you write also you should write like this. It's very complicated way to write. Better use the Eclipse editor. It will generate the code in accurately what way you want. Understood? So these are all the complicated things while overriding what? Hash code method. See, there are two different objects, but they are still having what? The same hash code value. Equals method is returning true, but still they are referring to two different objects. Still they are referring to different objects. So there are two different objects. Equals method is returning true. That is why the hash code of both the objects is also same. Okay, and hash code is also same. And one more thing is, we should, if you don't use that Eclipse support, no, you have to write it in this way only, no, which is very complicated. Clear? Fine. Now, after understanding this much, you got this point now? Clear? Yes. Now let's come to our first example and check it out now, how it works. Now we'll see the first example, which you already saw from the data structure point of view, how it is actually storing all of this. So let's look into this example now. So HashSet, set is equal to new HashSet. So when you do this, you know what is happening here? One hash table is created now, internally. Understood? So now I'm explaining how it works. See this, pay more attention now. So this hash table will have two parts now. One is what? The hash code, and the other one is the value. And this is what is your hash table. Why is this called as hash table? Because this is a table which stores your hash code and value. That's fine. Okay. Why is this called as a hash table? Understood now? Because it's using what? The hash code of your value to be stored here. Understood? So fine. Hash table. This is what is hash table. I've got definitions I'll be giving you. Understood? So then, and in this hash table, by default, there are 16 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Approximately, means if I have written it wrong also, just don't mind, but there are 16 empty spaces, we say. Or the hash set has got the capacity to store what now? 16 elements. The hash set has the capacity to store now 16 elements. Default implementation of this constructor. This constructor is like that. Okay. So now 16 empty spaces are there. These are all called as 16 elements can be stored. Or we can also say in other word, the technical word is there are 16 buckets or slots. 16 elements can be stored now. That's what books tell you. But technically what's happening? There are 16 buckets or slots which get created now. Now I'll add the first element. Means when you call now SOP set, it will print nothing. Is empty is what? True. Then if I print no values will be printed now. Now I start adding the values. C. So what happens now? The hash code value will be taken now. What is it taking? The hash code value. So some value will be there like 6, 9, 5, 8, 5. Then the value is C. Then you will have something like A. For that it will have some hash code value like 7, 5, 8, 6, 9, something like that, and A will be stored now. Okay. Then like that only for E some value will be there. 8, 6, 9, 8, 5, E will be stored. 9, 9, 8, 5, 0. Which one is that? D will be stored. Like this it goes on storing now. Okay, set dot add of F. So for that it will have some hash code value like 9, 9, 9, 8, 9. So this is F now. So like this it is storing. Okay, so it will take the hash code, it will store it in the hash code part, and the other value also it will be storing like this. And when you add a duplicate A, what happens now? So every time you went on calling add method, what was it actually invoking internally? Hash code method. It was getting the hash code. It was getting the hash code. And that hash code it will put it into one slot, and then accordingly it was storing the value. Yes, now when you add a duplicate like A, so what is the value of A? Hash code value? It will be same. When two objects are equal, what is the rule? The hash code will be same. So again it will, while inserting it will go to the same bucket now. When you are inserting a duplicate, I am telling you the reason why you can't add duplicate elements in HashSet. So it will take the hash code now. So it will go now. It is there. So hash code is same. Now it will check whether both the elements are same or not. Because two objects can be same, can have what? The same hash code, but they can be different now. The other way around you think now. Two objects can have the same hash code, but they can be different. So to check whether they are different or not, now it will call what? Equals. Understood? And now A will not be added. It will skip. But provided it was having if equals method was failing, supposedly one more element was there which is having the same hash code. Okay. And it was having the same hash code, but equals method fails. Then that would have been added. But that's not happening now. Okay, reason is what? Hash code means you go to that bucket, means for inserting it you go to that bucket. Okay, and then it will call the equals, and equals sees to that both are same, and it will skip the insertion. This is how it happens. Are you following now? So this is how the means you cannot add duplicates in HashSet, because add method will see what is the add method doing. Calls hashCode method to check which bucket to insert. So understand now, first it calls the hashCode method to check which bucket to insert. Now next, if element is found, then add method, this is step 1. Step 2 is what? If element is found, then add method invokes what? Equals method. Invokes equals method, and if both are same, it will never insert on. So this is how the duplicate elements will be skipped. Are you clear with this? Okay, fine. Then next, null value is fine, it can add, it will take the hashCode value of that and insert. So then size is empty set. Contains, yes, the contains is very important now. When you say set dot contains of e, now search is lightning speed, lightning, okay, because when you say contains of e, what it will do? It will take the hashCode, straight away it will go to what? To that bucket. First it will be calling what? Contains method is calling again what? HashCode. So straight away it will go to the bucket and checks in that bucket is the element e present. That's how it searches. Unlike array list and linked list, when you call the same thing list dot contains, how will it is checked? It will visit element by element and search. First index, second index, third index, fourth index, it will search all the elements. Understood? And then it will find whether the element is present or not. So the search time is drastically more where if you go for linked list and array list and all that. But in HashSet it is lightning speed, because it will be using the hashCode to search for the element. Understood? So straight away this is the most important reason why we use HashSet. See, it's very simple. You should know which structure to use when. You know the behavior, they allow duplicates, they don't allow, all that is fine. Okay, but see, if you want to visit all the elements, iteration, array list is the best. Okay, if you want to do too much of insertion, deletion and all, then a linked list is the best. If you want to store all elements in sorted order, tree set is the best. Now if you are worried about more searching, HashSet is the best. Okay, it has the best performance for searching. So one structure, data structure has one behavior. So you have which requirement in your project you use, but understand now already that data structure has been provided to you. You just have to use it. How will you use? HashSet, HS is equal to new HashSet or set is equal to new HashSet. Start filling the values. That easy they are done for you. Are you clear with this? Okay. So are you understanding? Now the buckets will be used for what? Storing key and value, key and value. This is how it goes on storing now. Done. So once this is done, yes, now let's come to the constructor of HashSet. You'll understand now more things. See, no book you'll find the information about HashSet this much. This is my experience what I am teaching you HashSet. Understood? So follow all this properly now, because it's very important, because you're going to use it in what? Real time also. SCJP also. Interview questions also will be definitely asked. Okay, next. See this. You have got some 4 constructor. You are using this one now. Yes? See, what does this tell? Constructs a new empty set. The backing hash map instance has a default initial capacity of 16 and load factor of 0.75. There's something like load factor. If you're not visible there, see this. What is the load factor? 0.75. Means as soon as 75% of this hash table is filled, again it will allocate what? Space for 16 more elements. That's the default implementation. So the buckets go on increasing. As you go on adding the elements, the buckets will keep on increasing now. Okay. And the default fill-in ratio is what? 0.75. 75. Fill-in ratio it is called. Means as soon as 75% of your hash table is filled, again it will allocate 16 more spaces. Okay. Then there is means if it is filled in 16 buckets now. 16 buckets means what? If 12 elements are filled, means somewhere here. If 12 elements are filled, what will happen? Again 16 elements space will be allocated or what? 16 elements like this it will allocate 16 more. That is the default implementation. Means always it will be maintaining extra buckets for what? Performance purpose. Understood? Fine. Next, there's one more you can constructor you can see. Means you know this constructor now. We'll come to that constructor later. 1 second. So this constructor, what is that? Int initial capacity. Supposing you don't want 16 elements or 16 buckets, then you can specify how much? HashSet set is equal to new HashSet of what? 8 I'll take. Any size you can give. 8. I just reduced it. If you want, you can increase it also. So what happens now? One hash table will get created with how many buckets now? 8 buckets. Approximately I'm rating. So it will have 8 buckets. Understood? So now default fill-in ratio is still what? 0.75. As soon as 6 elements are added, again it will increase. But by how many? 8. Again it will increase by 8 itself. When you add 6 elements, again it will increase by 8. So means when 75% of that is filled, again it will increase by 8. Now one more construct is there. Int initial capacity float load factor. Okay, so you can specify now. Initial capacity is what? 8. Load factor is what? 0.5. As soon as half is filled, it will allocate more. As soon as half of the hash set is filled, it will increase by how many? 8. Because you are told the capacity and you are telling the load factor or fill-in ratio, we say. Both same, no issue. Okay, so it will increase now. Okay, so that is your wish now. You decide how you want to create your hash table. Hash set. Okay, so now see this one more hash set is there. You know now you can send any collection. Supposingly there are some values in array list. Or the values in array list I can send it to what? Hash set. Why? I want to remove the duplicates in array list. Just what you do? Hash set is equal to new hash set of list. Finish. Create the list object and send now. So automatically means see from one data structure you are transferring the values into another data structure. So easy it is in Java. And duplicates will be removed. Any structure from tree set also you can put into what? Hash set. So assume that in your project you have got some array list created. Suddenly you feel that you want to do search operations or you want to remove duplicates. Now transfer all the values into what? Hash set. Understood now? So these are the 4 constructors now. Clear? So this is how the 8 buckets, when it is 0.5, how many? When 4 are filled, it will be increased. It will increase now. And that what value you are filling now is in the range of 0.0 to 1. Any value you give within this range. Understood? Don't give 5.5, 10.5 and all. So the fill-in ratio. Understood? So it should be between 0.0 means 0.25 means as soon as 25% is filled. 0.5 means as soon as 50% of is filled. 0.75 means 75% is filled. That is the best. Let us use the default one only. We will never use any other constructor. By default always you use what? The default constructor only you use. So don't bother too much about all that. This is the one we use always. But for your information I gave you all this idea. So you can specify the number of buckets you want. But they tell that is the number of elements it can store. Many books tell that is the number of elements it can store. But actually the fact is it is the number of buckets you want, you are specifying that. Technically if you see. Clear with this? Okay, fine. So having seen this much, let us see now what is hashCode. See, this is all internal behavior. You don't worry too much about all this. Just I am giving you all this idea so that you get good control over the data structures. Understood? Which data structure to use when and all that. And when you become, when you are coding with 4 years, 5 years of experience, that time you'll understand very clearly which data structure to use when and all that. Okay. We are going too much in depth. So you saw these things. Now next. So you'll see some notes. I had already given you the notes for what? HashCode method in Java. When I was teaching you class object. Some more information we'll see now. Okay, in Java, I think just increase the font. See, in Java, hashCode method acts as a hashing function. Understood? See, when you want to store your values in hash table now, you need what? Hashing function. In many languages, what you do? You write the hashing function. Very complicated it is. But in Java, you are gifted. How? In every class, you have the hashCode method now. By default, it is coming to you. You try to store your elements in C language, C++ language, you have tried what? Hashing function, and use that hashing function to add your elements into what? The hash table data structure. But in Java, what is the issue? No issue at all, because directly we are blessed with the hashCode method, which comes in every class. Understood? So in Java, hashCode method acts as a hashing function and generates the hash code for every object created. I'm just explaining what is hashCode method in Java now. Understood how it is used? See, every object in the Java system has a hash code. Every object. Why? If I don't override, default will be used now. So that's the reason. The hash code is a number that is usually different for different objects. That is usually different for different objects. Understood? But you should implement it in such a way that if two objects are equal, then the hash code should be same. You should implement it in that way. But the default implementation is what? For every object, the hash code will be different. The default implementation. Okay, even though their values are same. So that's what we are telling. The hash code is a number that is usually different for different objects. Usually. So JVM assigns unique hash code value to each object when they are created in the memory based on the object's memory address. So no two objects will have the same hash code when you use the default implementation of hash code method of class object. Never. If you use the default implementation, never they will be same. Never both objects will have same hash code value. Understood? Fine. Next. The hash code method returns the hash code value of an object in terms of integer. You know that? So it is, yes, that is becoming important now. It is this hash code value, okay, which will be used. See, it is, one second actually. Yeah, it is this hash code value which will be used when you are storing objects in Java collection classes that are using hashing like. More classes are there, so pay more attention to this. Other classes will become automatically easy for you. HashSet, HashMap, linked HashSet, hash table. The 4 more classes which use what? Hashing technique. So you get the concept here, that will be very easy. Done? Okay, 4 classes will become very easy to you know. Fine, next. Whenever we add an element in the collection classes that use hashing, like HashSet, HashMap, etc., hashCode method is invoked implicitly, which returns what? The hash code of the object. All these collection classes use the hash code value of an object to determine how the object should be stored or searched in the collection. Yes or no? When you are storing also, the hash code will play a role. When you are searching also, the hash code will play the role. No. Done. So all these collection classes use the hash code. Fine. Next. Now when you put an object in a collection that uses hash code, the collection uses the hash code of the object to decide in which bucket or slot the object should land. This is very important now. Getting it? Understood? So when you put an object in a collection that uses hash codes, the collection uses the hash code of the object to decide in which bucket or slot the object should land. Next, if you do not want to use existing hash code generation algorithm which is already available in JVM, you can use your own algorithm by overriding hash code. Hash code is already overridden for string class and wrapper classes. Yes, you know that. It is generally overridden for our user defined classes when we add them, when we want to add them into collection classes which use hashing like hashset, hashmap and all that. So until unless you have the desire to add your object into collection classes which use hashing technique, you don't have to bother about what? Overriding hash code. Understand this also now. Don't think overriding hash code is important in every class. It is only important when you are decided to add your collection class in when you want to add your object into collection classes. Only then it becomes important to override hash code method. Clear? Now what is the three terms? What is hash table, what is hash code, and what is hashing technique? Let's see this. See, hash table is also a data structure which can be used for storing values. Very simple. Now what do you mean by hash code? Okay, so values in the hash table are always stored after generating the hash code for that value. Means if you want to store a value in a hash table, first you should generate what? Hash code and then store. Otherwise you can't store. Okay, now the mechanism of generating the hash code for a value is called what? Hashing technique. Now who plays the role of generating hashing code for you in Java? HashCode method. Who plays the role? HashCode method plays the role of generating the hash code for you. That is the brilliance of Java. So it will be there in every class for you. Fine. So if you want, you override, else you leave it now. So clear with all this now? Yes. So when you are done with this much, we understood everything about hashing now. It's finished, nothing more. But only we'll see why it is so fast in searches. At last part we'll conclude. Understood? We'll see some program. I'll show you how to add employees into HashSet and all, and I'll show you how to search and all, and it will be fast also. Let's see that one now. Yes, see this. The next question. What is the advantage of using hashing technique? Why we take so much of headache and use this particular data structure? Simple reason is hashing technique provides very fast search rate. Unimaginable it is. Lightning speed it is. As compared to searches in other data structures, it is having very fast search rate. Then next, explain how hashing works. Now remember this point. Hashing retrieval is a two-step process. Means when you are getting an element, okay, it's a two-step process. First what it will do? Find the right bucket by using what? HashCode method. Second is what? Find the right element by using equals method. You have to find the right bucket and then you have to find the right element. So to put an element into the collection class, it should have these two methods. So better you override. For your classes, it's better you override now. Fine, done with this much? Yes, now we'll see about search. First I'll show you how to search what? Strings. Then I'll talk about searching user defined type. So we'll see two examples now. And those two examples are there in the same project. One more package it is, that's it. Search string demo, that's it. So add all your strings. Chetan, Ravi, anything you add. Duplicates, see, let's see how it is added now. And I say HashSet set is equal to new HashSet. What happens now? One hash table gets created. See now, practically how it works. In this hash table, it will have two parts. One is hash code and the other side it will have value. So totally it will have how many buckets now? 16, good. I can't draw all the 16 now, just understand 16 buckets will be there. When I add the first element, Chetan, for Chetan what will happen? It will generate the hash code and it will put it into one bucket now. The hash code will be put into one bucket. Supposingly for Chetan, I will take the value as something like, we are fine now. So I will take something like any integer value you can take, man. 5, 9, 8, 6, 5, something like that, and it will put it now, Chetan. Then you are adding the second element, Amar. Okay, like that, it goes on storing now. Amar, so it will generate now. Means actually, don't think, okay, I'll start it from the beginning only. So 5, 9, 8, 6, 5, something like that, it will generate and store it. Okay, then I'll store Amar 6, 9, 8, 5, something like this. It will store Amar. Then Ravi. 7521, Ravi will be stored. Then Kumar 89658. So don't worry about these values, I'm telling you. Understood? Vinay, okay, 959865, anything, any value. So it is Vinay. Like this, it will be stored now. So the 5 elements are stored. Clear? Okay. So now after storing, you try to add a duplicate. What means? See, I'll revisit this problem again and explain you. When I say add, first it will generate the hash code. It will put the hash code into the bucket, which one? Bucket, and along with that value. Next, Amar, again it will generate call the hash code method. It will get what? The hash code. It will put that hash code into the bucket and then the value. Like that it will go on putting. If you add a duplicate, it will go to the same bucket. No. Supposing I say set.add of Ravi, what happens? See, a duplicate is not allowed now. So what is the hash code of Ravi? This one, it will go to the same bucket. Now it will call what? Equals. After calling equals, it sees that element is already present. Now it will not insert. That's how the hash set works. So if you want your hash set to work properly, okay, see to that what elements you are adding in hash set are overriding hash code plus equals method. Otherwise they will not work properly. Means in string I cannot show. I show in what? Employee class. If you don't override equals and hash code now and try to add your elements in what? Hash set. Your hash set will not work properly. We'll see the problems. Done? Okay, anyway, this is how it's working now. When I say set.contains of Ravi, what it will do now? It will take the hash code, straight away it will go to the bucket. See, this is how inserting problem I told you. Then we are seeing the searching advantage. Okay, so when you search, what happens? It will directly go to that bucket. It will take the hash code and go to the bucket, and then it will check whether that element is present or not. Similarly, when you say get, okay, get method is not there, fine. Set dot contains, that's fast, it will search for you. Understood? Unlike which one? Array list and linked list. How it will search? When I say list dot contains, same values I'll add. Where? In array list. Chetan, Amar, Ravi, Kumar, Vinay. When I said list dot contains, how it will search? First element, it will call the equals method. Second element, it will call the equals method. Third element, it will call the equals method. Now it will say Ravi is there and tell true. So their searching is very slow in linked list, array list and all. But search is very fast in what? Hash set. That is why when you want to do searches now, always elements are stored in what? Hash set only. That is why it is very important in real life usage. This particular structure is important in real life usage because searching is very, very fast now. Are you clear with this? Okay. So to execute it will execute now. There is no problem. If I simply run the program, I will get the output. But that is the concept behind this example now. Are you clear? It is very fast. That's how I can say. Here you can't see the performance and all that, but it is fast. That much I can tell you. Clear? Yes. Now we'll come to our user defined data. The last example now. Understood. The last example now we understood overriding hash code, overriding what equals, everything you understood. If you don't override that and try to add it into hash set, let's see what happens. Understood now? Yes. So first I'll try to search on employee here. See this. Employee is a class employee. I will not override anything. What am I doing? I'm not overriding anything. Now see this. Search employee. I got how many employees? Employee 1, employee 2, employee 3, employee 4, 5 employees are there. Where all of them will be stored? In buckets. Employee in one bucket, employee 2 in one bucket, depending on the hash code. Which hash code will be used now? Default implementation of class object. So for every object it will generate one unique number. Yes? Now get this example. This is very important for you. Understood? So all objects will have what? The default, will be using the default hash code implementation of class object. Then I'll add all of them into what? Hash set. Now one more new employee I am creating. What happens now? It will have its own hash code now. Definitely it will have what? It will have its own hash code. Now if I check contains, you will never find it. Because what it will do? See here what is happening. There are 5 employees I have created. Employee 1, employee 2. Diagrammatically I will show you now. Okay, so first one HashSet is created now. Yes, it has 16 empty spaces. Now this is a hash code and this is value. So it will have some hash code like 5986. This is employee 1 and this is generated by whom now? Class object. So then because I am not overriding, so 76986 find employee 2, 7958 employee 3, 8659 employee 4, 9921 employee 5. So these are the 5 employees which have been added into what now? Set now. And every employee will have what? Its own values. This is the employee 1 object. It will have what? 101 AA. Now employee 2 is having what? 102. They are stored. They're, like that they will be stored now. I will write neatly for you. Five, 9, 2, 8. Some value you can write. Employee 1. Any value you can take the previous value only what I wrote. So this is employee 1 and what are the values? 101 A, like that it will be stored. What is this? Is one bucket now. This is bucket number 1. Then another bucket you'll have 6525. This is employee 2. It will have what values? 102 B, like this it will be storing. Then you're having one more now. 7513 employee 3. So again the 4 set of values, 103 C, 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 all the 4 values like this. 8521 employee 4. This is 104 D. This is how it is done now. Means after creating the objects, I am adding them in HashSet now. So then 9529 employee 5. This is 105 EEE. This is one object now. Done. So how many objects are there in HashSet now? 5. Getting it now? So now this is how it is there. And now I have got on user employee now. User employee is employee is one more object, different object, is equal to new user employee. It will have what values? Just directly means you call the setter methods and add the values. Call the setters and add it. So it is 104, 104 D and all that values are there. Now I'll say set dot. See, I am not overriding. So what will be the hash code value of this one now? Default one, and it can be something like 9999, something like this, some value. Now I'll say set dot contains of what? User employee. So it is now taking what? First it will call the hash code method of this. Where it will search? It will search for the bucket, not find. It will never find that bucket only. Only if it finds the bucket, then only you can search the element now. I told you when 2 objects are equal, they should have what? Same equals, they should have the same hash code. When 2 objects are equal, they should have what? Same hash code. Now it fails. So that is why when 2 objects are equal, they should have the same hash code. Otherwise, you can never search in the hash table. Understood? So it fails. That is why we override now. Understood? Now if you want to think this practically, what happens is, now from practical point of view, you know you have got an application. You know the drawing always I give you. What is that? This is the UI. You are entering the ID, he is entering the name, he is entering the phone, and he is entering his email. So these are the values the user is giving you. So what you have to do is, some data is there already there in what? Some data is already there in the database table. This is your table now. Forget this diagram now. This was different. I am showing you how it is done practically. So this was your table now. What is the table? Employee ID, name, phone and email. You will have this table. So what are the values you will have? 101, 102, 103, 104, 105. So this is your table now. A, B, C, D, E and their phone numbers 111, 222, 333, 444, 555. So this is your diagram now. Understood? So in this is your diagram. What happens is, see, it's a very simple scenario. You want to check if the user is there. Don't make him a member. The scenario I am giving you now. This is a scenario what you face in projects. Understood? So if the user is present in see, a new user is trying to become a member to the application now. Okay. So before you make a user into your application, what you have to do, first check whether he is existing or not. If he is existing, you should tell you already exist. If he is not existing, then you have to make him a member now. So how do you do that? Okay, so he is entering his values. What are the values he will enter? ID is 104, name is DDD, phone number is 444. Yes. So now, if you don't override, what happens? Yes, you will get the value into your application. Once you get the values into your application, you will fill it into what? One object. So when you don't override, this will have one different hashcode now. See, explain this in interview for you. This example, what I am telling you, you have to explain this only in the interview. Why do you override hashcode means, explain the practical reason why did you override means, this is what you have to explain. So when you generate means, you will create a new employee here, user employee. Why will you create a new user employee here? To store the values. So what is the values now? 104, DDD, 444, phone number, and this is your most important interview question. Why did you override hashcode or equals method in your project? They'll ask. Understood? So see now, one employee is coming. You have filled it into one user employee. Now the values from the database, what you are doing? You are filling into what? HashSet. You will retrieve it dynamically. We never hardcode like this. So all these values you got now. Same table. Think here now. Hashcode. Value. See, this is your application. Clear? I'll clear this now. I'm talking about the practical implementation. Don't get confused with this. This is over. This was from PSVM point of view I explained. Now we are seeing from the application point of view. See, this is a scenario. You got what? Hashcode is something like 59. Same hashcodes you write, but you are having what? Employee 1, employee 2, employee 3. So all the values from the secondary memory you brought it into what? Primary memory. From the database you have retrieved it. This is 101. This is 102. This is 103. These are objects. And they have put them into what? Employee 4. This is 104. Employee 5. 105. But if you don't override, what happens? What is the hash code of this? 999 or something we took. And this will have what? Its own hash code values. So see, a table you draw a little bit beside. You understanding now? See, the values in the row have been put into what? Your TO. This is one TO. This is another TO. This is another TO. This is another TO. This is another, so there are 5 TOs because there are 5 rows. So values from the 5 rows you have put it into 5 TOs. And those 5 TOs you have put it into what? Set. That is what I am showing you. Understood? Those 5 TOs you have put it into set. So now you will check set dot contains of what? User employee. Now what happens? You added all. Set dot add of employee 1, employee 2 you have added. Dynamically. Set dot add of employee 1, employee 2. Set dot add of employee 2. Then finally you will say what? Set dot contains. So you say contains, first it will take what? The hash code value of this. What is the hash code value? 999. Understood? So that hash code value is, it will search, it's trying to find the bucket. It will never find the bucket. With what? That hash code value. It will never find the bucket with that hash code value. When it doesn't find the bucket with that hash code value, it will never find the object only now. So it fails. So if you want to have proper searches in what? Classes which use, collection classes which use hashing technique, you have to override hash code, otherwise you will never search an object only. So I show you now, that is the reason it was failing now. Understood now? So just to explain this from the interview point of view. Now imagine, set dot contains, how fast it is searching. I have 10,000 employees. Directly it will go to what? That correct bucket now. If I have 10,000 employees, how it will search? If I put it in a list, one by one it will go on searching. So it will kill the time. So to increase our performance in applications, always we store the values in what? Set when we want to do searches. That's all about HashSet. Nothing more is there. I'll just execute this practically and show it, finished. Understood? See here, I'm not overriding what? Now, the same concept I'm showing in what? PSVM program. But generally in your code applications, this concept will come up now. Understood? So we have this employee, it's not been overridden. Now see, there's an employee with what? There's 104. You call the hashCode method and check off this. What you do for all the employees, employee1.hashCode, employee2.hashCode, employee, you print SOP employee1.hashCode, employee2.hashCode, for all the 6 you print, they'll be different. Do it like this here. Before you search, you print sys out of employee1.hashCode. Print for all. Definitely for user employee and employee 4, it will not be same. Because you are not implementing now, so the default one gets executed, and for every object what JVM creates, it will give its own unique hashcode. Understood now? So check like this. This one, employee 4 now, see here. And which one? User employee now. So it will print that reference, see this? See the bucket, sorry, the hash code. So you will try to find in that bucket, it will not find only. This is for employee 4. Employee 4 hash code is so and so. So when you are trying to search, it is going to bucket number which one? This bucket. Understood now? It will not find only. So it fails. So if you want to do the proper search now, what you should do? Not only this, even while inserting. Okay, first I'll complete this. So now what I'll do? I'll override. See this, it's that's why in Eclipse what happens when you're generating what? Equals. Along with that, what is generated? Hash code also. It is mandatory. When you override equals, you should always override what? Hash code also. Otherwise, it will not work properly in sets, especially in HashSet and all that. So done. So it is generated now. Now see, nothing I did. I took the help of what? I didn't write any logic also. I took the help of what? Editor. So easy it is for you now. See here. All I'll do is what now? See the hash code is same now. It's present now. That's simple man. Such a huge subject. Java has made it into a simple thing now. Understood? Such a huge subject. So both hash codes are same now. Because why? I am overriding now. And I see to that both objects which are equal have the same hash code. Done. That's simple. So done. So not only that, see when I'm inserting also, if you are inserting an element in what? HashSet, see there are 3 employees, 1, 2, 3 with 101, 102, 103. Employee 4 is there, but look at the values. A different employee, but his values are what? 102, B, so and so. If I try to add now, if I don't override, it will add. So I am not overriding. Searching is done now. We are going with what? Insert. See if I don't override, I am not overriding. See this, I am adding how many employees now? 101, 102, 103, 102. But 102 values are same. See what happens. I have added 4 and even you can see B is added twice. It will never think it is a duplicate. First its own hash code is generated. So it will be put into one separate bucket. Understood? See here what is happening. E1 is put into one separate bucket. Employee 2 is put in one separate bucket. Employee 3 is also put into one different separate bucket. Why? Because the default implementation of hash code is getting used. And all objects will have unique hash code. It will store now. Okay, but if I don't want this to happen, if you want to do duplicates now you have to override. See now only 3 elements I am adding now. What is that I am adding? I have created and now I am adding it also. See here, employee set dot add of employee 4. But it will not be there. Iterate and print. I am iterating and printing. Check this. It will not be present. Understood? So luckily for us now, when you are adding string wrapper classes and all now, they are overriding what? HashCode, and that is the beauty. So when you are adding strings, wrapper classes in HashSet and all, you don't have to worry. Their own implementation will be used. But when you want to add your classes into HashSet and all, better you override HashCode and equals for good performance. What is good performance here? Duplicates will not be added and your searching will not fail. That is the summary of HashSet. The summary of HashSet is only this much. When you want to add user-defined data into HashSet, override HashCode and equals only for one reason. Two reasons. What? Duplicates will not be added, and at the same time what? Search also will not fail. If you don't override, it will fail, and also duplicates will be added. That's all. Okay. And summary last. See, array uses what? Indexing now to search the element. What does a hash table use to search? HashCode. That's all. Very much similar. Very much similar. Array uses index, but this uses HashCode. But in array, indexes are created implicitly. Here we have to see to that our HashCode is generated. That HashCode generating algorithm, we write it in HashCode method. That's it. Same, instead of bucket, you think as index. That's the terminology. That is simply I'm giving an idea so that it makes you easy and comfortable. Are you clear this much now? So the last example what you saw, searching an employee, is the most important example of your lifetime. Lifetime I'm telling you. Okay, because whenever you develop any projects, this scenario is going to come 100 times. Okay, whenever you are adding an element into the database, first you have to check whether it is existing or not, and then you have to add it. So you fill all the values into what? HashSet, because search is very fast. If you fill the values into array list, recently I had shown you filling the user defined TOs in what? Array list and all that. You can fill there also. But remember, when you fill in array list, when you want to do fast iterations, when you will fill in linked list and all, when you want to do too much of insertion and deletions, when will you choose HashSet now? When you want to do fast searches. Tree set, when you want to store it in sorted order. That's all. Very simple. Okay, it's not rocket science here. Java is brought down data structures down to earth for you. Clear? Okay. So that's about insert. If you don't override, these two problems you will face now. Any questions here? So the last example what you saw, search employee, this one is very important. Okay, this is very important. I'm telling you, V to the power of, I don't know, million times. Okay, throughout your lifetime you'll be referring to this example. Understood? As well as at the same time I've shown you what, if you don't override, insertion also fails. Wherein, because it will not treat that as duplicate. But search is very important. This also is important, but search is very important. Finally, to conclude, yes, explain how hashing works. You got it now? Shall I clear everything now? Got this practical implementation? So see, I'm here to teach you concepts, and you have to understand the concepts, because you can't take my example and start putting into what? Real life programming. So you should get the concept such clearly that whenever a scenario comes to you, you should know how to pick the data structure. So clearly I explained you all the concepts of all the data structures now. Okay. Anyway, one more class I'll be taking where I'll summarize all the data structures and I'll be concluding which one to use when. Lastly, I'll take that because still some more structures are pending, which are linked HashSet and all is pending. I'll complete that and then we'll discuss. Yes, now, why should you override hashCode and equals method? Simple interview question. Be ready with that answer. We should override both these methods so that we can use efficiently for searching and storing in collection classes which use over one statement. Understood? Then what happens if you don't override hashCode method? Actually, the question is what happens if you don't override hashCode and equals method? It's a 2-in-1 question, but I split it. What happens if you don't override hashCode in one place? I've written equals. Okay, the collection classes which use hashing technique to store elements will allow duplicates to be inserted. Yes, if you don't override hashCode, it will allow duplicates to be inserted. And also we can't search a particular object or element in the collection. Searching also will fail. Insertion also it will allow duplicates. That's now we are discussing. Yes, why? Because means why it happens? Because if you don't override, the default behavior of hash code is to generate a unique integer for each object on the heap. So if you don't override, no two objects of the same type can be considered equal. Simple concept. Lastly, okay, yeah, what happens if you don't override equals? This you know. The default behavior of equals method always checks what? Whether both the reference variables are referring to the same object. If you want to compare to contents of the two objects, then we have to override equals method. How does searching work in HashSet? Simple answer. The search object means the object which you are using for searching user employee. Understood? And the object in the collections must have identical hash code values and return true for the equals method. Two things. It should have the same hash code and it should return true for equals method. This is how the searching happens in HashSet. Clear? Simple conclusion. So what a massive subject of hash table has been made so simple in Java. Clear? So just practice it 2-3 times and it will be easy for you. Okay, and this is definitely in your SCJP interview. SCJP, okay, we are targeting for SCJP more. SCJP interview questions, real life usage, that important this example is. Understood? And lastly, to conclude, what is this hash code you have generated? What it is generating? Don't bother too much. See, it is generating something. But what you have to understand is it's better you use what? All the instance variable values. Better you use, when you are checking equality also, better you check for all the instance variable values. When you are checking what? Equality. And when you are generating hash code also, better use all the instance variable values and then generate the hash code. Then you will have a perfect one. Because you will see to that, never two objects will have what? Same hash code. So when two objects do not have the same hash code, definitely your search is lightning speed. Because every object will have what? Separate bucket. Every object will have what? Separate bucket. Yes or no? Because all the hash codes will be what? Different for every object. So when the hash codes are different for every object, what happens? Every object will be stored in one bucket now. But if I return 999, what will happen? Yes, to conclude now. All objects will be in the same bucket. And now it has to call equals. It will go to the bucket. But now it has to go on calling what? Equals on every object. When it goes on calling on equals object, what happens? Efficiency reduces. Search reduces. Speed. Time. So in that case, if you are not, if you are providing some fixed value like this, it's better you could have gone for what? Some other structure only. Understood? So that is why don't return any value like this, fixed value. If you return the fixed value, problem is all the objects will land in the same bucket. And your search will become very slow. Understood? See to that your object will get a different hash code only. That is why I am using all the values and generating the hash code. Here it is guaranteed that no object, means when we override, also it will never have the same hash code. And also when you create identical hash code, what happens? Sorry, when you create an identical object, hash code will be same. Also when you create an identical object, hash code will be same because it's using what? The same values of instance variable values. Means creating an identical object means that object will be created when the user makes a request. Dynamically it will come. Creating identical object means we will not create. See, this is the application. So this object will put on T or no. That is what is, we call it as search object or identical object. And this object will be searched with what? Your hash table. Understood? So see to that, when two objects are identical, they have the same hash code, otherwise you can never search. Clear? So can you write this logic? Very complicated now. So better what you do? Generate it. So the Eclipse is that friendly for you. Same way, equals method. So complicated. Generate it. Done? Any questions you're having, ask. And if you have questions, gradually when you go on coding, every day in your life you'll be using this. It will be cleared. You don't have to worry also. Just you need what? Practical exposure now. I've taught you theoretical. You only need what? Practical exposure. When you develop an application, you'll get it and all your doubts will be cleared also. You don't have to worry about any doubt. It's only practice, coding and being practical by developing what? Applications. You don't have to worry about anything here. This much is more than sufficient for you. Clear? Fine. I think lastly we'll summarize with what is HashSet. Simple. What is HashSet now? HashSet stores the elements in a hash table. Yes. Now you should understand all the points now. It uses the hash code of the object being inserted. Duplicates are not allowed. Then values are stored in unsorted random order because it will be storing somewhere in the buckets. We can't expect the order here. Okay. And it will not be stored in the same order as inserted. Different type of objects are allowed. Null value is allowed. HashSet can use only iterator. And HashSet provides very fast search rate because it uses hash code. That is all you have to understand about what? HashSet. Nothing big here. In interview also these 7 points are more than helpful for you to clear. Understood? Now difference between HashSet and tree set. These are also your interview question. Differences and similarities. Yeah. HashSet stores elements in what? Hash table. That stores in tree data structure. Elements are unordered or undefined. We don't know what is the order, but there it is sorted. We can add different type of objects, but in tree set we can add what? Similar objects. Null values are allowed, but only one. Understood? In HashSet you can add null value, but how many? Only one null value. There in tree set, null values are not allowed. It provides very fast search rate. Compared to this, it is very slow. It will search, but compared to this, it is very slow. That's what I am telling you. It provides very slow search rate. Now both are synchronized. Both are similarity now. Similarities, both are not synchronized. Both do not allow duplicate values. Both are eligible for cloning. You can clone if you want. HashSet.clone. Automatically you'll get one more. Serialization we'll discuss. Okay, both can use only iterator and use only iterator but not list iterator and enumeration. All notes clear. This much of notes if you know, definitely you can clear any interview also. Yeah, that's it then.